Sorry. So I'm here to try and tell you about why you need to learn to code, but I think that you probably know this already because it's probably all been driven down your faces many, many times. We clearly need to code because we can all become professional programmers. Right? That's why we need to do it, because there's a shortage of jobs and we need to fill that shortage by learning how to code ourselves. And what a complete utter nonsense. Like, do we teach kids in schools PE so they all become professional sports people? No. Do we teach them maths so they can all become professional mathematicians? No. These are important skills that will broaden our sort of perspectives of life, but they aren't the most important things. Well, being a professional whatever is not necessarily the most important thing for learning that thing. I like to try and sort of take a few steps back. And imagine you were in a field, you've been a farmer all your life, all your friends are farmers, all you know about is chaffing the wheat and doing your farming business. And some person comes from town wearing fancy clothes, and they're working in some sort of legal structure or something, and they wanting obviously to buy your farms to turn into a factory, and they come along and they say, you need to learn to read and write. And you say to them, why do I need to bother? I can just do my farming business. I don't need to do reading and writing. It's really important. You need to learn to read and write so you can write legal documents and so you can read religious tomes. And this is the kind of the argument I think people are making about coding right now. And it's pretty frustrating because they're not very engaging. They're not necessarily things that you're going to want to do. And so I think that to try and start the conversation of why we need to learn to code, I think we need to have more interesting, engaging, and relevant motivations. I think if someone, instead of coming from a legal background to the farm, came and said, here's a story, but to read the story, you need to be able to understand what the letters mean, and it's a beautiful story from another part of the world, and you can learn new things from it, perhaps that might be a bit of a motivation. Or if you know how to write, you'll be able to write some ideas down that you'll be able to remember in 50 years' time by just simply looking at the crazy characters and being able to remember what you thought a long time ago. I think these are much more interesting. Or that fabulous recipe of yours, if you want to share it with somebody else on the other side of the world, well, if you write the ideas down with these crazy symbols, then I can take them on this weird paper thing, on a horse and cart and boats, and take it to somebody else, and they can recreate your recipe or your musical ideas. Does it make sense? So I think we need to try and find ways that engage people that are relevant and meaningful to them, not necessarily things which are for any kind of commercial requirements, which is currently, I think, the day-to-day. Right, that's my rant. I wanted to get that over because I think it's really important that we start to understand what we could do with code and not what we can do with code. And I don't think anyone really knows what we could do with code yet. Really, I think we are very, 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 very early on in the development of programming and computers. Just think about in terms of things like geography or astronomy, or like in the early days, geography was really about compasses and using compasses to figure out where to plot your land so that the rivers wouldn't flow them over. And astronomy was about telescopes. We don't call astronomy telescoping. Why do we call computing computing? We need to somehow realize that we're still extremely early on in the development of these things. And whatever people are telling you today may be relevant in 5 years' time, may not be, but really, we still have no idea where to go. And we really don't know what those exciting things that we can do with computing are that relate to the analogy of reading and writing. We're still working with computing like it's legal documents, or like it's some kind of formalization that's important for business, which it obviously clearly is, but that's not necessarily what's going to excite you and engage you. And more importantly, I think, it's not necessarily something that's going to help you express yourselves. And I really believe, that programming opens up a world of new possibilities for people to be able to express themselves in new ways. And that, to me, is incredibly exciting, because I've got no idea what those ways may or may not be. And I'm really interested to see what they might be in my lifetime. And it's a shame, because obviously the really exciting things are going to come beyond that. Does that make sense? So I think that when we talk about trying to teach people how to code, and that's not just to children, it's to adults just as much, we need to find ways that engage them. And for me, that's not necessarily what engages professional programmers today. When you ask me what excites me, I might say sorting algorithms. I love sorting things. How many of you like sorting things? Not very many. But this is what we teach kids. This is how we sort things. And okay, in the approach of learning how to sort a series of numbers into ascending or descending order, there is lots of interesting computer science that can be extrapolated and understood. But no one's listening. No, as soon as you say the word sorting, they're all switched off. So we need to find ways which excite and engage people and that are relevant to them in their lives now. So for me, I think one of the things I'm trying to do is look at media and particularly look at music. I think it's much more interesting to say to a child, rather than say, let's learn about lists, to say, let's learn about baselines. Instead of let's learn about functions, let's learn about melodies and sections of rhythms. Or instead of let's learn about iteration, let's learn about drum loops. Okay, these are interesting, like drum loops, I'm into that. But how do I make a drum loop? What is a drum loop? Well, now we have an interesting question. We can start to give an actual deconstructed analysis of what a drum loop could be. It could be a list of drums, which this is the first drum, this is the last drum. We need some way of playing each drum in sequence. Okay, now we're starting to talk about computer science, and we can actually start talking about how a computer can model these things. And more importantly, we can get the computer to actually play our drums back, so we can actually do some drums rather than just talking about these things, or printing a list of all numbers in order. I mean, no one's going to run around the room shouting, "This is brilliant," when they see 1, 2, 3, 4, 5 printed on the screen. That makes sense. And my timer is still on 25 minutes, so I have no idea how many minutes I've got left. So I literally, it's just now it's just started. Hopefully it's going to go down. Okay, so this makes sense, right? I just wanted to do an introduction. So I've invented something. It's on the screen here. It's a piece of software. Normally when I watch myself, these talks, recordings, I always forget to tell people what I'm actually doing. I just get into it straight away. So I'm just trying to pause a second. This is software. So this is a program you can download that's running on my computer here, but it runs on any computer. It runs on a Mac, a PC, and also it's installed by default on a Raspberry Pi. And so you can run it literally anywhere. And it's entirely free. And if you're enjoying what I'm going to do for the rest of this talk, you too can go home and download this software for free and play with it yourselves. That's the most important message. So what I'm trying to show you here with this is not magic, actually. I think technology can be perceived as being magic. We've seen it talked about before. But I believe that we should make it less magic in many ways. Because if I said to you, look at the things you can do with technology, but only I can do them, that's pretty useless. What I would like to be able to say is, look at the things that technology can do. And if you like this, then it's dead easy for any of you to do this as well. Right? Because I want everyone to be engaged. I don't want it to be something only special people in the magical circle can do. I want this something that everybody can do if they're interested and if they want to. And I also really, really fundamentally believe that the philosophy we should adopt with technology is that if the technology is too hard or too complicated, that is not the person who's using its fault. It's the person who made it. It's their fault. So if you were to use this, which I hope some of you will do, if not all of you, and you struggle with some part of it, that's my fault. And I apologize now already in advance. And I hope that you might send me an email and say, Sam, I tried to do this, but it made no sense. And I'll do my best to A, help you, and then B, change the system so the next person comes along, hopefully doesn't have that same problem. And in fact, that's how I've developed this application over the last 4 years. The first 2 weeks were academic blue sky research, where I imagined something which could be cool. And after that 2 weeks, for the rest of the 4 years, I observed children and adults alike using the system, and those observations fed directly into, I need to change this, or, I didn't imagine they would do that. That's nuts. That's not their fault, that's my fault. I'll fix the system and make it simpler. Okay? So, and the other thing is, when we get into the classroom or when we get to any kind of context, if the starting point is incredibly complicated or really difficult, as we saw with opening the mobile phone in the box, just all these pieces just pop out and you've got no idea where to assemble them, that can create a barrier to entry. And so I guess the fundamental sort of philosophical approach I take to teaching computer science is attempting to lower the barriers to entry. And so if one of those barriers is cost, if I say, well, you need a £2,000 computer, that's obviously a barrier to entry to a lot of people. So my software runs on the Raspberry Pi computer, which is £35. So hopefully that lowers the cost barrier. The other one is, and also the software itself is entirely free, so there's no cost there. And then the other two are, how do I even start? Well, when you get this installed, there's this help button you can click with a full tutorial built in, so you can learn everything I'm saying today and much, much more in your own time. And thirdly, how easy is it to do anything? Well, let's think about this. If I wanted to make a note, I'll just write the word play, choose the note to play, and now I have my note. So the first program you can write creates something that you can hear and perceive, that's something that's real, and also hopefully you can see that's not too hard. And then you might think, well, what is 70? Well, I could go into detail about that in terms of mathematics, but I'm not. It's just a number, right? And what do numbers do? They can go up and they can go down. That's great. So in computing, what we do is all the time is try and find these things, these mathematical things, and map them onto the real world. So if numbers can go up and down, what else can go up and down? Well, pitch can go up and down. So if I choose a higher number, like this, I get a higher note. Or a lower number, I get a lower note. That's all it is to it, you know? And of course, you could go along and apply some Western theory to this if you wanted to, and that's totally available to you. But why would you? Why not just say, do you like that note? Well, it's okay, but I think I can imagine a better note. Well, there's a better note in your head, a higher one or a lower one. And then just choose a higher or lower number and just keep doing that until you find a good note. Like, don't worry about what people have been doing on pianos and guitars, because that's historic. Actually, we were limited and constrained by the fact that the instrument that we were using was both the interface and the thing which made the music. And that added these constraints, which are no longer there. We're free from that. We don't have to have a piano with N keys. We can have a piano with a million keys if we wanted to. We don't have to work with tuning systems that try and combine these systems. We can use whatever tuning systems we want. We're free to do what we want. So really, I think it's the great place. And also, if you say to people, to use this system, you need to understand Western music theory, I think that's a barrier to entry. You can apply that if you want to, but you do not need it to get started. So there we are. And then we might want to play two notes, for example, to make a melody. Let's play note 80, then note 85. Ooh, well, that might have surprised you. You might have thought maybe it's going to do one note and then the other. In fact, it does, but the computer is so incredibly quick, it sounds like it's played at the same time. So this is an extremely interesting opportunity for learning to talk about how computers are incredibly quick things. And so when you give them instructions, they will go one after another very, very quickly. So we need one more instruction at this point, which is to sleep between the notes. Now we have a basic program which gives us the ability to make a melody. And at this point, it's really important to say that basically all of Western music, pretty much, you can model with these two commands. Isn't that crazy? So any melody, any bass riff you can imagine that you've heard, your favorite one, with these two commands, you can recreate. Well, I think which is cool, because it means kids now can start making music with just two commands, and they really, really, really do. But of course, this isn't where you end. This is not the finishing point. This is the starting point. So if the starting point for music with code is pretty much most of Western music, can you imagine where we can go? Can you imagine that? Now, I can't. I have no idea if you can, but it's exciting to imagine the possibilities. And we can start to do all sorts of cool things. Like, so if I change the sounds, that's a different command. There we are. And I can change it to... or... we're already into different... I mean, this isn't that exciting at the moment, but at some point then we can say, okay, well, what about duration of notes? Well, I can change the release time of this to be short, and this one a bit longer. Or let's choose another one. Let's think of another sound. It's quite a nice one. It's very quiet. Let's have another one. More like drums. It's quite fun. And then how about this one? Well, that's quite fun. So we can play around all these sounds, and if we look at the documentation, I'm not suggesting you can see or read this, but you can see lots of different grey boxes. They're all the knobs you can change to change the sound of this. So you're not limited to what you just heard. You can really go crazy and change all of these sounds. And already all I've done is shown you how to make some notes and wait between the notes and change the duration of the notes and change the sounds with just a couple of commands. But what else could you do? So another thing you can do is you can play pre-recorded sounds. So let's play a guitar recording. So this is someone who played a guitar, I've recorded it, it's now inside the computer, and with a single command I can play it back. Now that's quite fun, but what about being able to modify it? Let's change it to play at half speed, or quarter speed. So just by changing the rate, I can completely change the feeling of this sound and the duration. What about this? Does anyone know what that might do? It's pretty crazy. If I walk forwards at 1 speed, that's fine, right? That's good. If I walk forwards at half speed, that's pretty good. But what happens if I walk forwards at minus speed? Going backwards, right? So what does that sound like? Interesting, right? So you can take any sound. So there's a bunch of sounds built in. There's about 100 of them. They're all public domain, Creative Commons Zero license, so you're free to use them. But of course, you can also record your own sounds, download your own sounds from your favorite artists, and mix and mash them together with a system. And already, I've only shown you the absolute basics of this, but when you give this to children, they go absolutely nuts for it already. So here's some children in a workshop we did at Cambridge, at the Cambridge Junction, which is an arts venue. We had a whole week where we taught them how to code, how to make music with a code. And at the end of the week, which is this point here, their parents came to see them demonstrate their work, and then they all did performances on stage, like a stage like this, you know, and with their parents and an audience. And it was a fabulous experience to watch. Here's one of the children doing his demonstration there, right? So, pretty cool. And of course, we don't have to stop there, okay? It's really important to talk about how things are simple to use, right? And that's the message I'm trying to give to you, is that technology does not have to be mystic. It can be completely demystified if we work with people who help us to understand that it's their problem as technologists to make it simple, not your problem to understand the technology. So getting started is really important, but you also want to make sure that there's depth, right? So I can say to you, I can teach you how to play all the notes on a piano. That's really easy, of course you can. Or I can teach you how to play all the notes on a guitar. You just need to show them how to make a note, and then you move your finger up and down. Done. But why would you bother? You bother because there are fabulous pianists that you've seen. You think, oh, I'd love to make music like that. Or fabulous guitarists you've seen. You think, they're my role models. How on earth do I do music like them? And so I'm trying to start to figure out what a role model might look like. And there's a whole bunch of people doing this around the world. It's what we call live coding. And they've all made their own systems, and they're all kinds of different crazy systems. My system is, as I'm describing, attempting to make things simple, but also trying to make sure that the depth and breadth is there. So this is me performing in America at a Moog Fest, a big, massive synthesizer music festival. And the festival was covered by the Rolling Stone. You know, and they featured this, and they said that Sam Aaron transcends the present. So he's like a computer scientist in one of the most important music magazines in the world. And I think that this really shows how there's potential for using technology like this in new ways to engage new audiences. And it's not just about making money for businesses. It's about finding ways that people can express themselves. So let me just spend the rest of the time just to show you the kind of things you can do with the system before I run out of time. So, of course, this is the school mode we have. We also have a nightclub mode. We don't want those buttons, and we want it to go to full screen. And this is important, because when I performed in Frankfurt a couple of years ago, this guy came and went, this is brilliant, absolutely loved the music, it was amazing. But that big white screen behind you, too bright. You can't have that in a nightclub. So we have the dark mode. And so there's one thing to look at is that, for example, I can do things like, let me think about what I'm going to do now. This is a lot of fun. So if I have a sample E-bit ARP, and I got that in there, yeah. That's built-in sample, and if I can filter it down, get 120 BPM at C minor. Right, this is a standard sample that I've downloaded and bought, but it'd be really fun to be able to mash it around. So if I choose onset 0, it just pulls me the first note, and the second note, and the third note. We count from 0 in programming for some crazy reason. So, and then I can put this in a live loop, which is a way of repeating the thing, and sleep for a short amount of time. This is quite fun, right? That's already going. So now I can start changing this number and exploring the notes. But I can also pick them. So now I have an infinite random stream and get another live loop. Let's call it beats. And play sample bass drum house and sync for half a beat. And I'm going to synchronize this so that at the same time with food. Right, and already this is very, very simple. We can start to see how this can grow in complexity. And then I can say, well actually, every 8 times, I'd like to reset the random seeds, which means that I get the same choice. You see what I'm doing here? It's very, very simple. Just changing these numbers around. And so at this point, when I practice a couple of hours a day, I just think about, I listen to the music and I think, well, where can I take it? What would be interesting? So at this point, I think, well, maybe a more complex beat might work, or maybe some guitar sounds. So for the rest of the 1.5 minutes, I'm just gonna, is it okay? I'm just gonna make some music and just to see where I can take it. I've got no idea. So usually I have another live loop, which is a bit longer. I'm going to call this Hello. I'm running out of ideas. Sync it with Foo, and I'm going to play sample arrow vein beats, 24 beat stretch. There's always a nice one to work with, C for 8. My time's up, but I'd like to just, if it's possible, say another 30 more seconds of words. The first thing is that everything in this system here, every idea, I can teach to a 10-year-old child. So really, if this looks complicated, it's not. It's just different. And secondly, that when we start to perform electronic music like this, rather than play pre-recorded things, then it opens the audience up to seeing actual performances, which I think is exciting, which means you can make mistakes, like I did. And then you can fix the mistakes, just like a guitarist might break their guitar or break their leg, right? These are important things, that, as has happened, right, with Dave Grohl recently. And I think so. We need to actually. I think we need to challenge DJs. We need to challenge electronic music and say, okay, great, you've got virtuosity in the studio. That's great. You can make a CD. That's awesome. Can you go on stage just like Jimi Hendrix could and kick ass on stage? Probably not. You can do that. Right. So I think we need to find ways to actually challenge these people and say, well, actually, can you take your virtuosity from the studio and onto the stage? And what will that allow us to do? Can we imagine a punk rock for electronic music? And can code provide us new ways to do that? And then more importantly, can we use code not just to make music, but to express ourselves in all sorts of manners of ways, which doesn't necessarily relate to business and making money? Thank you very much.